Okay, so 4.2, the zeros of a polynomial function. This would be day number 5, last day. You know that what happens with last day. In this video, you will see the application problems for section 4.2. Okay, your application problems, so let's get right into that, see what we're talking about. Take a second and process. Read letter M to yourselves. Take a second, pause your video, read that to yourself, see what we're talking about in this situation. So, I want to talk to you about some things and realize what's happening here. Scientists, obviously, they use radar to map the ocean floor. So think about this. You're on a boat, and what happens is that you sail out to a certain point, and I'm going to show you. I'm going to get rid of all this stuff, and I'm going to make another slide. I'm going to clear this out. I want to show you what I'm talking about. Okay, so I want you to imagine, and my drawing is going to be terrible, so you might as well start laughing now, and I know you're going to enjoy this. So imagine here is, right, here's the water, and what's going to happen is you're going to have a boat. Yeah, buddy, that's my boat. I'm going to put a little flag on there. Woo! Put, I don't know, let's say that's Mr. White House right there. And he's in the boat, and what happens is they sail out to a certain point in the ocean, and believe it or not, they have this contraption that comes out of the bottom of the boat and gets to a certain point in the water, and what'll happen is you'll have an ocean floor that kind of looks something like, that, and what happens is once they hit the button, this box here will take a picture. Using radar, it'll kind of determine what the bottom of the ocean floor looks like. So think about it. If I wanted to turn this into a graph, I know that my graph would look something like this. So notice that it's underwater, but for the ocean hills, well, they're going to be represented by positive numbers. The valleys are going to be represented by negative numbers, okay, even though it's still underwater. So what you need to realize is that you're not taking it from like the shoreline. What happens is they get to a certain point, they go out a certain distance, and then they drop this box, and that box is at a certain height. And what our job is to do, and I want you to kind of forget about all that math that you've seen, what our job is to do, so you can see some things that I would highlight. Let's back the train up a little bit. It says ocean trenches appear as negative values and underwater mountains as positive values. So think about that picture that I just had there. That's kind of what it's saying, and I think that gives you a better understanding of wrapping your brain around this. Think, this is the domain of my function because I told you we only want to go to a distance 12 miles from the shore. Okay, so we're talking about a distance for 12 miles from the shore. So it says in letter A, obviously here is the function that I'm using, right? Here's the function. Letter A talks about use the remainder theorem. So think about what the remainder theorem is to find the height of the ocean floor 10 miles out. So I know to use the remainder theorem, I'm given the number to use, so that's the number I'm going to plug into my synthetic division. Looking at my function, do I have any terms missing? Do I have to hold any zero place values? I don't, so I don't have to worry about that. So there are my numbers. Again, you should be able to do synthetic division from this point. So I get a number of negative 216, right? The remainder theorem says to simply take the remainder, and that is our answer. So it says, use the remainder theorem to find the height of the ocean floor 10 miles out. So to figure out the height of the ocean floor, well, I would say that it would be 216 feet, and because it's negative, I know that it's in a trench. Okay, so the height of the ocean floor 10 miles out would be 216 feet. And it would be 216 feet because obviously, like I said, it's negative. Negative numbers are represented as ocean trenches, so I know that's got to be in a trench. All right, so letter B. Let's think about it. It says, use the tools developed in this section to find the number of times the ocean floor has a height of 0 in this interval, given that it occurs 12 miles out. Think about what a height of 0 means. It doesn't mean that, okay, all of a sudden we're in our boat and we're going to hit land, right? Understand that that's not what it means. Think about, let's go back to our picture. What it means is, how many times does our ocean floor match the distance of this box? So like there would be 0, there would be 0, there would be 0. So it's not that the ocean floor is going to automatically rise and you're gonna sink your ship. It's obviously, we want to know when it's level and when it's equal to that box. So think about when it equals 0. I'm going to talk about that. So how can I figure that out? Well, I know it occurs 12 miles out. So here's my hint. I know that at 12 miles out, it should be equal to 0, so that means that this should be a 0 of my function. Well, I know if it's a 0, I should get a 0 remainder when I do my synthetic division, so that's what I'm going to do. I'm going to set up my synthetic division with using the number 12 because it told me at 12 miles out that the height is going to be 0. It gave me that hint. So let's do our synthetic division. It looks like we're down to that there. So if I think about what I have left, my remainder, my constant, my x squared, and my x cubed. Alright, so I'm thinking if it's x cubed, I'm going to try to factor it by grouping. I'll leave you to understand that you can't factor this by grouping. It's not going to be possible. When you try to factor some things out that are in common, it's not going to work. So that means I got to do my synthetic division one more time. So how can I find another 0 in order to do my synthetic division from here? Okay, how do I find another 0? Well, you should be saying to yourself, well, to find another 0, I can always go to my graphing calculator, graph this function, and look to see where another 0 occurs, and hopefully you do that. Let's go to our graphing calculator, type that in there, find where that goes. I'm not going to do that. I'm going to assume that you're going to take it upon yourself to do that. I'm going to kind of just get to the point. I know that positive 1, it looks like when I graphed it, positive 1 was another 0. So at positive 1, I'm going to do my synthetic division again with what I have left. Remember to drop that 0. So do your synthetic division again. Lo and behold, I got a 0 remainder. Look at what I have left. Think remainder, constant, x squared. I know I'm going to be able to factor this. Anytime it's down to an x squared, I'm always going to assume that I can factor it. Okay, how do I factor it? You should be saying to yourself, okay, multiply to get this, add to get that. So negative 8 and negative 4. Set them equal to 0. Well, it looks like I get 8 and 4 as those two. obviously the other two that I found were positive 12 and positive 1. So I would say that the ocean floor has a height at 0, 8 miles out, 4 miles out, 12 miles out, and 1 mile out. Okay, so obviously it's going to hit, and it's going to be the same height as wherever that box is at those different levels, at those different distances. So hopefully that makes sense to you. Obviously we're going to do some practice in class tomorrow, yeah, good job.